Increasing and decreasing functions. So, basically we've kind of already touched on this. If your gradient's going upwards from left to right on a graph, your gradient's positive, which means your function is increasing. If your gradient's going downwards from left to right, i.e. it's negative gradient, it means your function is decreasing. So when your gradient's positive, your function is increasing. When your gradient's negative, your function is decreasing. So state whether the function f of x equals 5x to the 4 plus x squared is increasing or decreasing at x equals negative 1. So f of x equals 5x to the 4. Differentiate, we get 20x cubed plus 2x. At x equals negative 1, so f dashed of negative 1. We get 20 lots of negative 1 cubed plus 2 lots of negative 1, which is negative 20 minus 2, which is negative 22, which is less than 0, so the function is decreasing at x equals negative 1 because the gradient is negative. Next time a question you'll get asked is find the intervals for which the function f of x equals x cubed minus 3x squared plus 8 is increasing and decreasing. So we're going back to our nature tables again. So f of x equals x cubed plus 3x squared plus 8. So differentiate f dashed x equals 3x squared minus 6x equals 0 for stationary points. Note we don't need to find the coordinate y coordinates of the points. We just need to find out where the gradient is positive and where the gradient is negative in these intervals. So common factor of 3x can come out. So 3x brackets x minus 2 equals 0. So either x is 0 or x is 2. So looking at our nature table, we're coming up to x equals 0 and away from x equals 0, up to x equals 2 and away from x equals 2. So if we pick negative 1, we're going to get positive and positive, so we get positive. 0, when we put something in between 1 and 0 and 2, we'll put 1 in. So 3 lots of 1 is 3, minus 6 lots of 1 is 6, so that's negative. So it's negative here as well, 0. And for 2, we can put in 3 if we wanted. So 3 squared is 9 times 3 is 27. 6 3s are 18, so it's positive. So here it's a positive gradient, here it's a positive gradient. So it's increasing for all values of x less than 0 and for all values of x greater than 2. And it's decreasing between 0 and 2. Last type of one you're going to get is where it says the word show algebraically. So we can't use our nature table. We've got to show it. It does feel like you're kind of hand waving. So show algebraically that the function f of x equals x cubed minus 3x squared plus 3x minus 5 is never decreasing. Basically we have to show the gradient's either 0 or bigger than 0. So here f dashed x, we do the differential and then we factorize it. These will be factorizable. It might be you have to put it into a difference of 2 squares. It might be that it's a straight factorize. So if we're squaring something, whenever we square something, it has to be greater than or equal to 0. Because if we square a negative, we get a negative. And that's for all real values of x. We're not talking imaginary values here. Real values of x. So when we square something, it's got to be 0 or bigger. So when we times it by 3, it's still got to be 0 or bigger, which means f dashed x has to be 0 or bigger, which means the function is never decreasing. Had it been one where it was show it's always increasing, we might have had to do a complete the square, and it might have been plus 1 or plus 2 or something, in which case we would have done the same thing here. It's squared, so that's always got to be bigger than or equal to 0. When we times it by 3, it's always got to be bigger than or equal to 0. When we add 1, it's always got to be bigger than or equal to 1, which means it's never going to be 0, which means it's always going to be increasing.